Hello, everyone. This time we are going to talk about types of black holes. And there are three types we're going to talk about: stellar mass black holes, supermassive black holes, and miniature black holes. So first off, let's talk about stellar mass black holes. These are black holes that are created in the normal life cycle of a star. So we're talking about very, very, very massive stars, stars that have already gone into that red giant stage. And when they start to run out of fuel and they go into a stellar collapse, instead of stopping at a white dwarf, instead they keep collapsing and collapsing and collapsing down so that core is past that Chandrasekhar limit, and the core just keeps collapsing upon itself, and you end up with that black hole. Stars, who's going to become a stellar mass black hole? Stars that begin their life 10 to 100 times more massive than our sun. As we've discussed in the past, our star is a dwarf star. It is just not big enough to become a black hole, probably a good thing for us. And when it goes supernova as part of this implosion, and then there is a rebounding explosion as part of this process, that black hole is going to be created as part of its normal life cycle. And those are called stellar mass black holes. Now, there are other kinds of black holes out there, and they're called supermassive. I love the name supermassive black holes, which gives you an idea that they are like really, really big. These contain millions or billions of solar masses. The other ones were 10 to 100 solar masses. Now we are into the millions and billions of solar masses. Where do we find these? We find these at the centers of galaxies. And as we talk about galaxies next chapter, we believe that supermassive black holes are essential for the creation of a galaxy, that you must have a galaxy at the middle of you must have a black hole at the middle of a galaxy in order to make that galaxy form and create that gravitational tug to get that beautiful pattern of that galaxy. Now, how do you get a supermassive black hole? We believe it's by a combination of multiple black holes. These are large gravitational bodies. And so you have one big gravitational black hole and another big gravitational black hole, and there will be a force of gravity that will attract one to the other, and each one very often has some motion, and so they spiral in towards each other, and they combine to create something with a larger mass. Well, bigger mass means more gravity, and then they can continue to add more mass and more mass. You do not build a supermassive black hole overnight. It takes many, many, many millions and billions of years, and they are huge, huge beasts. They also have very large and very subtle event horizons. If you recall, for every one solar mass, it is a 3-kilometer wide event horizon from one edge to the other. Well, if you have something that is 1 billion solar masses, you have a 3 billion kilometer wide event horizon from one side to the other, which is about 2 billion miles. So the edges of these event horizons are very subtle. These are the ones that we think may be hazardous to future astronauts that are going out in the distant edges of the space, because they are so subtle, but the same rules apply. If you go over the event horizon of any black hole, you will never get out. No information, no light, no electromagnetic waves, no radio waves, no gamma radiation, and no matter will ever get out of a black hole. It will be trapped and eventually end up in the middle. Mini black holes. Mini black holes are theorized. There is no proof that they exist, but you may have heard of Stephen Hawking. Dr. Hawking passed away not that long ago, within the last decade or so. He was a regular on the TV show Big Bang, so I don't know if you watched Big Bang, but that may be where you saw Dr. Hawking. But one of the things he hypothesized was miniature Big Bangs, miniature black holes. And at the moment of the Big Bang, when the universe was created, he hypothesized that matter could have been pushed together with enough force to create little tiny pinhead black holes. Now we're talking about, honestly, things about the size of a pin, but they have the mass of an asteroid. So something much smaller than the moon. Imagine something bigger than a house, but smaller than a moon. So about the size of a mountain, but having that much mass, but the size of a sewing pin head. It is thought that in the beginning stages of the universe, there was so much gravity and such big pushes that these tiny black holes could have been produced. Where have they been looked for? They have been looked for in the large particle accelerators at CERN. And as of writing this video, there is no evidence that they actually did exist. Over the last 20 years, many people have looked for them, and at this moment, none have yet been found. The other thing that Dr. Hawking theorized is something called Hawking radiation. Again, not been proven. And he hypothesized that black holes would eventually evaporate. They would not last forever. Space is not emptiness. Space is something. And that out of the energy, background energy of space, he hypothesized that particles could come out of the soup of this background energy, and you could get a particle and an antiparticle that could be produced on the edge of this black hole, and that one could fall out of the black hole, one could fall into the black hole, and that through time, this energy would slowly take energy out of the black hole, and it would reduce the size and evaporate the black holes. Again, this has not been proven yet. Maybe in our lifetime this will be proven to be so, but as of this moment, it does not exist. But you'd like to know what's being out there in the science world. All right, that will do for this time. See you later. Bye-bye.